Hello again. In this video, we're going to continue with section 4.5, modeling with power functions using directly and inversely proportional. So before we start exercise 2, let's review that. So y is directly proportional to xn. If you have that situation, then the formula is going to be y equals k times x to the n. If y is inversely proportional to xn, then y equals k over xn. Sometimes other books will use varies directly, so y varies directly with xn, means the same thing, and y varies inversely proportional with xn, means the second one. Some of my old videos in my topic section is going to use those words, which is exactly the same thing, to warn you. Okay, so with that being said, see if you can try exercise 2. So you try this, pause it when you're ready for the solution. Are you ready? Let's do it together. We're looking for a formula for y in terms of x if y is inversely proportional to the square of x. So y is inversely, means over, and we have the square of x, so we're going to do x squared. So that's what that means. Find a formula for y in terms of x if y is inversely proportional to the square of x. So we really haven't found a formula until we find k. So now we're going to find k. So how I'm going to find k is they always give you a piece of information to be able to find k. So they say y is 0.25 when x is 5. So I'm going to put 0.25 in for my y. I don't know what k is. And we know that this is 5, so we have now a 5 squared. So I can do that work over here. How I'm going to do that is make this k over 25. I'm going to multiply both sides by 25 here, and I get 6.25 equals k. So they're looking for the formula. So step 3, just make sure you answer the question. They ask us to find the formula, so it's going to be y equals 6.25 from my original over the x squared. So the k is going to stay the same. The x and the y can change. So when x increases, what does y do? Does it increase or decrease? And the answer is increase. Oh, inversely, sorry, decrease. I was thinking it was direct, but it's inversely. We know that it is a decrease because the p in our power function is -2, and the graph is going to look something like that if you graph that on your calculator. Example 4. If you know it's a power function, you can actually find the p and the k. So suppose you have y equals k times x to the p. You know it's some power function, but you don't know which one. We don't know if it's direct or inverse. So we're going to figure it out. It says find k. Is p positive or negative? Optional exercise, find p. So let's go ahead and do that. To find the k, I'm going to use this one because it turns out when y is 4 and x is 1, if they give you x is 1, 1 to any power is always 1. So this would just be k. So we know that 4 is what the k is. So the formula would be 4x to the p. To find the p, you won't be tested on this, it is optional, but to find a p, what you're going to do is use another point. So let's use the second one. So we know that when y is 1, x is 2. How do we do that? So I'm going to isolate the exponential. Now this one, you can see that p is going to be -2, right? Because it's a fraction. 2 to the -2 is 1/4. So p is going to be -2. Using logs, you can also solve for p. But since this is in section 4.5, the book doesn't think that you have done logs yet. Okay, so that is that. Example 5. What happens to the area of a square if we triple its size? So let's look at that one. So I drew a little rectangle here, and I tried to do 1. Let's call this x. And let's call this x because it's a square. And I'm going to triple it. So the area of the first triangle we know is x squared, which, by the way, we know that the k is 1, and that's directly proportional to x squared, isn't it? Okay. If I triple each side, so this would now be a 3x. It's not quite proportional, but you can see it looks like about triple there. And this one is about 3x. Now if I find the area of the large one, the area of the large, we'll call that area of the large, is going to be 3x times 3x, which is 9x squared. I'll change this to area of small. This makes sense because area of a rectangle is length times width. Okay, so I could say since. So it looks like it is 9 times it. It makes sense because if you put a 3 in here, we get a 9, right? So it means that the area of the large square is 9 times the area of the small square. Area of large is 9 times the area of small, or you could say in words. So here is the answer. There it is right there. The large is 9 times that of the small. Let's try another one. Exercise 3. Find a formula for s in terms of t if s is proportional to the square root. Try that. It just has proportional, so that means directly. Go ahead and try that. Come back when you're ready. Okay, here's the solution. It says s is proportional, means directly again, to the square root. That one also works of t. It's still a power function. The t is equal to 1/2. So it's still the formula. The first one. Okay, so we know that when s is 100, we don't know it. K is, I'm doing step 2, finding the k, so I don't know what it is, but we know that the t is the square root, or the t is 50. So we have the square root of 50. We can divide both sides by the square root of 50 and get k is equal to 100 over the square root of 50. And you can simplify this. You can make it a decimal, whatever you want. I'll go ahead and simplify it. What I'm going to do is I'm going to make it 100 over 25 is perfect. So I'm going to make this 25, times 2. Yep, that's 50, which is 100 over 5 times square root of 2. So we get a actual 20 over square root of 2. You can also rationalize that. Maybe I'll do that later. But that is a fine answer. So let's go ahead. It says find a formula. We just did. Again, if you feel like rationalizing it, you're more than welcome to, because we also know that you can multiply this. Let me do it maybe over here. By square root of 2. So you would get 20 square root of 2 over 4, square root of 4, actually, which is 20 square root of 2 over 2, which is 10 square root of 2. So you can write this as 10 square root of 2 t as well. Sometimes I like putting my t first even. 10t square root of 2. Any one of these answers. Or you can get a decimal if you figured out what 10 times square root of 2 is, or 100 over square root of 50. That should work as well. Last exercise. The volume of a sphere is a function of the radius. So notice how this is proportional. It's a power function because pi is a constant. power function where P is 3. So it's directly proportional, we can see, to the radius. The volume is directly proportional to the radius cubed. So let's just see what happens. Plugging in these values. Go ahead and try this and come back when you are ready. Here's the solution. The answer to part A is 8. You can do this several different ways. You can figure out the top separately, figure out the bottom, and divide it. What I did is I just plugged it in all at once. So 4/3 pi, the 6 cubed, over 4/3 3 cubed. I noticed that these canceled, so I just ended up with 6 cubed over 3 cubed, which was really 6 over 3 cubed, which is 2 cubed or 8. But you can do that however you want. Okay, what about f of 2r? If you got this one right, continue on. If you did not get part A right, try it again and see if you can plug in and simplify 2r, f of 2r. Here is the answer. So this time, since we have an r, we can't just use our calculator. So we're going to have plugging in a 2r into the r. That's what that means. And then I'm going to use my law of exponents, 2 cubed and r cubed, which makes an 8. So it looks like we have this extra 8. So it's 32 over 3, which helps us on this one. What happens to the volume of the sphere if you double the radius? Think about this for a minute. For part B, especially if you did not get part B correctly, and see if you can figure out what happens before you go on. Okay, here's the solution. So the volume of the new is just this, f of 2r. So I realized that I had that 8 there, so it's 8 times the old volume. So the new volume is 8 times the original volume. This is 8 times the volume of, we'll call it the old. And there it is. Hope that helps.